Good day. My name is Moses Kamana, student number 18596444. My project name is titled Smart Room Temperature and Lighting Controller. In this project, I designed and stimulated a microcontroller-based system and monitors room temperature using LM35 sensor and light level using an LDR. Based on these values, the system automatically controls a fan and LED lamp, and it displays all values on an LCD screen, a 16 by 2 LCD. I have the system. This system is useful in real life applications such as smart homes. Smart homes officers, classrooms where automatic control helps save energy and keeps the environment comfortable. By automating temperature and lighting, we reduce manual effort and improve efficiency. The systems works as follows. The LM35 sensor measures temperature. The LDR sensor measures the light intensity. These signals go through an ADC 0804 and 74HC4051 multiplexer. The 8051 microcontroller reads the digital values and makes the decisions. The LCD displays temperature, light level, and mode. If the temperature is above 30 degrees Celsius, the fan will spin and will turn on. If the room is dark, the LED light turns on. A push button allows switching between automatic mode and manual mode. Here is my Proteus design. I use the ATC 89C51 microcontroller as the brain of the system. The LM35 temperature sensor is connected to the multiplexer and the ADC to convert the analog value. The LDR is connected to the major light. The ADC 0804 converts signals to digital for the microcontroller. Then the 74HC4051 multiplexer allows us to switch between the LM35 and the LDR inputs. The 16 by 2 LCD displays the temperature, light level and mode status. The fan is represented by the DC motor and it is driven by a transistor. The LED lamp, the LED yellow lamp, is also controlled by the transistor. A push button switches between automatic and manual modes. This is how I connected all my components all together. As you can see, all the wiring. I'll just zoom. This is how they are connected throughout. Then now I will show you my coding. I'm going to start a new project. Then I will write it MCD26. Then I'll save the project. Then I'll search for 80, 89, C51. Yes. Then I'll add a new line of which we'll use C language. Then I'll save the file name as MCD26. I'll add it. Then I'll paste my code here. Okay, let me paste my code. Then I'm going to create a hexa file. I'll just click on the target and I'm gonna choose output and say create hexa file and say okay. Then I'm gonna rebuild. You can see the 0 errors, 0 warning, and build time released. Then now I'm going to put the hexa file inside the microcontroller. To put the hexa file, I'll just double click on the microcontroller and go choose the file. My file is MCD26 hex file. Then I'll just choose it and say open and say okay. Then now I'm going to simulate and demonstrate how the system automatic. Now I'll demonstrate the system in automatic mode. I'm gonna run it. As you can see now, it's on. Everything is on 0. Everything is still off. Even on the display, the LED is off. The fan is off. I will start by demonstrating with my fan. When the temperature is above 30, the fan is supposed to spin. I'll increase my temperature on the LM35 temperature sensor. As you can see, when I'm increasing my temperature LM35, the temperature as well moves here. Let me carry on. It's supposed to be more than 30 degrees Celsius. It's above. As you can see now, the fan is starting to spin. It's starting to spin the fan. It's on now. Even then you can see on the display, it's written fan on, just because of the LM35 have increased and the temperature is above 30. Then I'll demonstrate also the LDR. So when my threshold is above 35, the LED will be on. Let me increase the LDR. You see now it's above 35. It says 37. The LED is on. When I take it back to less than 35, it will be off. It's on 32. It's off. I'm taking it back. It's on. Taking it. It's off. So now we're gonna turn off the fan. The temperature must be less than 30 so that it can be off the fan. We'll just go back to our LM35 and turn it back to 0 so that it can be off. Now I'm demonstrating my automatic mode. So now the LED and the fan are off. The fan is still going on because of the temperature is still above 30, but I'll just take it back to 0. It needs to be off when it's on 0. everything on 0. Everything is on 0 now. My fan is supposed to be off. As you can see, everything is off and the fan is gonna be off. Look at the speed. It's when it says 0, the fan will be off. Still counting. Still counting. It's on 6. Now it's on 0.50 something until, let's wait until it goes to 0 so that can be fully off. You can see now it has stopped. Then now I'm going to simulate the manual mode. Now I'll press the push button. This is my push button to switch mode. So when I press the button, the LCD will show manual. As you can see, it's A. When I press the push button, it will say M. As you can see now, it's on manual mode. And the fan is off. Then when I press manual mode, the fan is supposed to be on. I'll just click it manually, then the fan is on and it will spin. The LED will respond to the LDR automatically. The system works correctly, the sensors respond accurately, the fan and LED react in real time, the LEC displays all the information clearly, the mode switching works perfectly. One challenge I faced, I was controlling 2 analog sensors with one ADC, but I solved it by using an 74HC4051 multiplexer. I also had to carefully adjust the transistor circuits to make sure the LED was not always on. Conclusion, I successfully designed and stimulated a smart room temperature and lighting controller using the 8051 microcontroller. I learned how to interface sensors, use ADC and multiplexer, write embedded C code, and control outputs based on conditions. In future, this system could be improved with wireless monitoring, smartphone control, and real hardware implementation. Thank you for watching.